Wherever you are, you can join us as we lift up our voice and bless the King of Glory. Maybe I will be a true suffers and a kind of your boy. Sense of Fatase or Gia, be anyone in the same.
Welcome to our today's lesson on graph of quadratic equations. Okay, normally in quadratic equations we learn how we are going to solve them. When you are given the equation, you want the roots of the equation. In this particular video, we are going to look at how, if we are given the function and then a set of domain, we are going to draw the specific graph in that regard. Okay. Now, what makes an equation quadratic? No, generally, every function we have has a certain variable and then coefficient. So, for instance, if I have a function, say f of x, and this function has a variable, say a, and then b, and c, and d, like that, and then they have coefficients this way, and then a variable, say x, and then another x attached to this very coefficients. It goes on and on. Okay. Now, if it is cubic, then it means that the highest power of this. So let's say this is n minus 1, n minus 2, n minus 3. It goes on and on like that. So this is actually the general formula or the general approach to every single function. So if we say this specific function is quadratic, then it means that the highest power of x becomes 2. So for instance, I made my n is actually 2. That is the meaning of quadratic. So if we say cubic function, that means n is 3. So when you put n in the general formula you are having there, then my function for quadratic becomes a x to the power 2 plus b, then you see 2 minus 1, so that's bx1, then plus c, and then this c has x attached, so 2 minus 2, and that is going to give you 0, and any number raised to the power 0 from indices lesson is 1. So you are going to have the general equation for quadratic as f of x is equal to ax squared plus bx plus c. We know this, and then we've established this fact. So if it is cubic as well, then you are just going to say n is equal to 3. So you are having 3, 2, 1, and then 0 like that. Okay. So we are having this situation. Now, if you have a quadratic function and you are asked to draw the graph or plot it on your graph book or whatever as this, normally this is actually going to be a 2D figure. So with the 2D, we have just the y-axis and then the x-axis. So for every quadratic graph we have it to be in the form of either a minimum or a maximum. Okay, minimum or maximum. When we treated coordinates, we realized that we have linear functions, so that one the graph will be in a linear format. And I made mention there that in quadratic, the graph is going to be more like a curve. Okay, but this curve, the shape of the curve depends on the parameters within this specific function. Okay. So we have minimum curve and then a maximum curve. So minimum curve and then maximum curve. Okay, minimum curve and then maximum curve. Now, what accounts for the graph to be called a minimum curve, and then what accounts for it's being a maximum curve? All depends, like I said, the parameters that are within the functions. Specifically, the coefficient of the x squared. Now, if the coefficient of the x squared, which is a, if a is positive, Okay, if A is positive, A is greater than what? 0, then you are going to straight ahead have what? A minimum curve. If A is greater than 0, then you are going to have what? A minimum curve. That means that the shape of the graph is going to look more like this. This is what we call what? A minimum curve. It goes to the down and then curves back. Okay, minimum. So that is when your coefficient of S squared here is positive. Okay, then it's going to give you a minimum curve. Then when the coefficient of S squared here is negative, then it's going to give you what? A maximum curve. So the curve is going to go more or less this way. Okay, so this is for when it's negative, and then this is for when it's what? Positive. So we have these two situations. Okay, so even if you are given any function, that is in terms of what? Quadratic. So you are given any quadratic function, so you want to actually draw, you must have in your mind or an idea of how the shape of the particular curve is going to look like. Right? So you must have in your mind that this particular curve, per the function given to me, is going to be maximum, or the function given to me is going to be minimum. So that when you are computing something and you are getting certain values, you can actually say, no, this curve is supposed to be maximum. How come I'm getting a minimum curve? Okay, so the checking criteria is what I mentioned to you, that if the coefficient of x squared is positive, then it's going to be minimum, and then if the coefficient of what? X squared is negative, it's going to be maximum. Right. Now, every quadratic equation has roots, or basically every equation has roots. So the number of roots depends on what? The highest value of x. So for instance, this particular one, the highest value of x is 2. Okay, so meaning that it should have 2 roots. 2 roots means that we will have 2 answers for our variable. It's either this or that. Okay, so x is either 1 or 2. If it is cubic, you have 3. If it is to the power 4, you are going to have what? 4 roots or 4 answers for your variable. Okay, so then that is what is actually going on here. So with this one, we are going to have 2 roots, and we can use the solution where we multiply a by c, get the factors. After getting the factors, we factorize and all that, and come out with the roots. That's the formula way. Or graphically, we can also get the roots. Okay, so these are what we'll be looking out for. It being minimum, maximum, and then we'll be looking at what? The roots of what? The quadratic equation graphically. Okay, we'll be looking at the roots graphically. Right. And also, because of the nature of quadratic equations, it exhibits some level of symmetry. Okay, it exhibits some level of symmetry. So there is always line of what? Symmetry for a quadratic graph. There is always a line of symmetry. Now, it's just bilateral. Only one line of symmetry. It doesn't have multiple. Okay, so it only exhibits only one line of symmetry. So with this one, we're also going to identify graphically what a line of symmetry is. Okay, so we'll be looking at the line of symmetry too in this code. Okay, line of symmetry. Okay, in this lesson. Right. Then also, after it's getting line of symmetry, we can actually find the gradient of the curve at any point at all. Okay, supposing we have this curve here. Supposing we have this curve here, so let me redraw it well. Here. So this curve, and it's bigger, and then we identify this curve on the Cartesian plane, this, and we want to find the gradient of what the curve at this point here. Okay, it should be possible for us to find the gradient at that point. Okay, it should be possible to find it. So we'll be looking at the gradients of what the curve, the gradient of the curve at a point. Okay, so we'll be looking at the gradient of the curve at a point. So when we get this few ones, there could be more questions asked on what the graphical look of quadratic functions. Okay, but the most important thing about drawing of quadratic graph and equations is getting your graph right, getting it spread across the whole graph book, 3/4 of the entire space. Okay, meaning that you must choose a very good scale for your interval, and then you must choose label your axes very well and all those things. Okay, because those are what actually fetches the mark. After you are done with representing your whole function graphically and neatly done, then we can then proceed to find the minimum or maximum curve, the minimum or maximum value, or the roots of what the equation that you've drawn, or the line of symmetry, or the gradient at a certain point. Basically they can ask you say use the same curve to find the roots of a particular line and all those things. Okay, so that is what we are going to be dealing with in the subsequent video, where we are going to pick a full question, give you a function, and then we are going to plot the function and identify all these parameters that we've listed in there. Okay, then we shall be able to know how the graphs are drawn for you. Okay, so let's quickly. In our previous lesson, we learned what this particular concept is about, what is required of you, and then what you might be asked, okay, after drawing your graph, and how the graph shapes are supposed to look like depending on the function you are given. Okay, in this video, we are going to take a function and draw it, and then find out various kind of questions within it, under it. Then we are going to see how the whole concept looks like. Okay, now let's start. Okay, supposing we get a function, let's represent f of x by y, so that we can say my function is x squared minus x minus 2. So supposing I give you this as what the function on the domain minus 3 less than equal to x less than equal to 4. Okay. Now in our coordinates video, we learned about what domain is. Okay, and so we realize that this domain means that x is starting from where? -3 and ending at 4. We said that if this underline wasn't there, or the is equal sign that is there wasn't there, then that means that x is going to start from -2 up to 3. Okay, for both sides. Right? Good. Now, some of the questions also give you intervals. Okay, the intervals for which the domains are separated. When it's not mentioned, take it as 1 unit, so that this will be separated -3, -2, -1, 0, 1, and it goes on. Okay, but if the interval is given to you as 0.5, then that means this is going to be more like -3, then the next is going to be -2.5 before -2, then -1.5, -1, like that. Okay, so that the interval between it is going to be 0.5. Okay, so depending on the interval they have given you is what you are going to use. But if interval is not mentioned, then you assume it to be what? 1 unit. Okay, good. So with this specific one, there was no interval mentioned. Therefore, we can assume That is 1 unit. Right? Good. And we are supposed to plot this quadratic graph. The questions are going to come after we finish the plotting. Okay. First of all, let's plot it. So, just like we do for plotting every function, you have to construct what? A table relating the domain and then the codomain. Okay? So this is going to be the domain and then this is the codomain function. Right? So then this is going to be, you construct your table nicely. Some of the questions may even construct a table for you, leave out certain values in the codomain and ask you to actually find them. So that one will be copy and complete. So you already know it, you are just completing the table. Okay. So then this one, just nicely draw your table. We have our x value and then our y value. So this, that, do the divisions by the domain. So -3, -2, we have, this is too large. So -1, 0, 1, 2, 3, and then perhaps 4. So we have to do that quickly. Do the divisions for your domain. Very well. So now that you've done the division for your domain, then what is up next to you is to fill in your section of codomain, which we learned in our function video. Okay, or coordinate video. Alright, so let's go. We have -3, and then that is the image we are supposed to find on this particular function. So it's like put the -3 into this function. So it's going to be -3 squared minus -3 minus 2. That's going to be the first one, where your x is -3. Okay. So then -3 squared is 9. 9 minus will be plus, and -2. So this is going to be virtually simple. 9 plus 3, 12 minus 2, and this is 10. Neatly. So this is 10. You do same for this one. At least, if the table is long, we do not expect you to show all the working of the individual inputs and all those. No. We are after completing the table. Okay. But for the purpose that you should show that yes, you didn't copy or something, you need to actually show working for a bit 3 or 4. Right, then the rest you can just fill in the table using even your calculator. Okay, very simple. But you must at least show some level of working before you go there. So this -2, when you put in that, my y there is going to be what? -2 squared minus -2 minus 2. So this is y is going to be 4 plus 2 minus 2, and that is going to be what? 4, right? That is going to be 4. So my next value is 4, and then we go on to say this is y. So the other one, when x is -1. So here you can just write when x is equal to -3, when x is equal to -2, like that. Just label it for them to know this is what you are dealing with. Then this one is when x is equal to -1. So you put -1 in the function, then you are going to have y is equal to -1 squared minus -1 minus 2. So just inserting -1 in place of wherever you find the variable. So this one here is going to be 1 plus 1 minus 2, and that is 0. So you are having that one simply to be 0 over here. Okay, then 0 into this function here is going to be -2. So you can just quickly do the insertion, right, on your own. For time factor, let's just quickly forward in doing the insertion. So we are having, putting 0 in here, 0, 0, minus 2, putting 1 there is going to be 1 minus 1 minus 2. So 1 minus 1 is 0, so this is also -2. You can see clearly That. Then when you put 2 in here, this is going to be 4. 4 minus 2, and that is going to be 0 as well. So this is also going to be 0. And then when you continue and you put 3 in there, so 3 squared is 9. 9 minus 3 is going to be 6. Okay, 9 minus 3 is 6. Then 6 minus 2 is going to be 4. So virtually repeating this side. Then finally you put 4 in there. 4 squared is 16. So 16 minus 4 is going to be 12. Minus 2 is supposed to be 10. Okay. So virtually this is what you are going to have. So you are having your equation being, having your codomain being from 10 to 10, ranging. Okay, ranging. Good. So immediately I'm done completing my table. Then all I need to do is to go to my graph and then what? Plot it. So let's quickly go to the graph book and then what? Plot whatever we have there, right? Now, before we go there, the scale we have to choose. If you should look at the interval from here, -3 up to 4, means that we can use 1 centimeter to even 2 centimeters to 1 unit on the x-axis. Okay. As for scaling, you have to learn how to scale. Okay. The division on the y-axis are actually what? 12, and then the division on the x-axis are actually 10. Okay. So if it is 12 and you use 1 unit, you know that the maximum is 12. So even if you should look at the y-axis, you realize that the maximum here is 10. So if I use 2 centimeters to 1 unit, it will still work. Okay. So that one then, depending on what you want to use, the scale you want to use. But like I said, you must always choose a scale that will make your work spread 3/4 on your graph sheet. Okay. If we are lucky enough and the question gives us the scale to use, then hallelujah. If not, and you are supposed to look for your own scale, then you should please make sure that the scale you choose will spread very nicely on your graph. Having said so, let us quickly move to our graph and then plot what we have. Yes. So we are here on our graph. So this is the table we are drawing, and then we are supposed to translate this table onto our graph. Okay, onto our graph here. Now, before we start every plot, okay, we need to first of all establish the axis. Like I said, we need to label the axis, and then we need to get the division. Okay, we need to get a division. This is the horizontal, and then this is the vertical. But the horizontal has these divisions over here. So these are called the horizontal divisions. It divides the horizontal. And then this is what? The vertical, and then this divides what? The vertical. So I'll refer to this as the vertical division and then the horizontal division. Don't be confused about that. Okay, so we are having this plot. Now, if you look very well from the angle I'm looking at with the domain, okay, which is the x values, it starts from -3 and ends on 4. Basically, you realize that with this specific one, both sides are balanced a bit, because -3 and then 4. This is where the negative side and then the positive side, they are almost the same. So you can actually decide to divide your graph into what? 2 equal halves, because like I said, the horizontal divisions are 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different divisions for the horizontal. So if we have 10 divisions and we divide it out exactly equally, that means we have 5 for the negative section, and then we have 5 for what? The positive section. And I believe this is less than -5. Same way, this is also less than what? 5. So definitely we can divide our graph into what? exact to equal halves. Okay, so let's draw our y-axis, which will divide the horizontal into, so we have 1, 2, 3, 4, 5. Same way from here, 1, 2, 3, 4, 5. So exactly this line is our point of interest. So this line, okay. Pardon for using freehand. So this line. All right. So you put your ruler on this and rule a straight line. Okay, downwards. Now that is for the vertical division. So you can label it your y-axis. Okay, you label it your y-axis, and then you now need your x-axis, right? You need your x-axis as well. So if we have your x-axis, you must also look at what you have here. Now with this here, the positive values we are having is up to 10. But whereas the highest value for the negatives we have here is -2. So it will not make much sense to say then, okay, then I have to also divide my graph into what? Equal halves. No, it won't make sense. Because we have 12 different horizontal, 12 different vertical divisions for this. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divisions. So if there are 12 divisions, then it means that if I divide this into equal halves, meaning I will get 6 for the positive and then I will get 6 for the negative. But I do not need up to -6 for positive, and I need more than 6 for the positive, right? So definitely it means that smartly I need to shift the division, the main division, the axis, more into the negatives so that I can create more space for the positive. But how far can it go? Now we already have 6, so if we are using 2 centimeters to 1 unit, it means that this must further go down by about 4 divisions. Okay, so it must further go down, right? So if you are having this here, then we can say that, okay, then let's draw the line here, basically. So we are drawing the line here, okay? So we draw our line here. So then this becomes our x-axis, okay? So you label your axis, and then here, where the x and y meet becomes my origin, 0, 0, okay? So I have my y-axis, and then my x-axis, right here. Good. Now after you getting your axis, then you need to label them. Okay, you need to label it nicely like the way I've done it. Then you indicate the various demarcations on it. Good. So we have that. We are using 2 centimeters to 1 unit. So every 2 centimeters, 1 unit. So 1, and then this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. This is 9, and then that is what? 10. So I've been able to create more space for my positive up to the highest value, 10. Now, I need to do so for my negative as well. So I have -1 over here, and then we have -2 at this place. So the very last line is -2, and then this one is what? -1. Okay, so now with the vertical axis numbered very well, let's now do that for the horizontal as well. So this one also goes 1, then 2, 3, 4, and then 5. Okay, then the negative zone will be what? -1, -2, -3, -4, and then -5. So this one there is equal division, 5, and then what? -5. Very well. So now that we've established this, we can now translate whatever is on our table onto our graph. You can translate it to the graph. So let's go on. So we have at negative 3 on the x, at negative 3 on the x, we have 10 at the y. So at negative 3 on the x, we have what? 10 at the y. So you put a plot over there. Please, this is the only approved way of what? Plotting a point. We don't do anything like this. What is this? This is not a point, okay? These are lines that are intersecting, okay? This is the only thing we know as a point. This, okay? Don't do this or anything around, no. This is the only approved. So try and do that for us, right? Good. So we have minus 3, 10. So we've plotted that. Then the next one is negative 2 on 4. So minus 2 on 4, right? On 4. So negative 2 here. Then we have 4 over here. Good. Then the next one is asking us what? Then minus 1 on 0. So minus 1 here, 0 on the y-axis. So there is no movement on the y-axis. So minus 1, 0. So here, it's going to be here, definitely. Okay, so let me remove the origin so that it doesn't confuse you. Okay, so in this place. Good. Then we go to 0, negative 2. So when x is 0, y is minus 2. So y is actually minus 2 over here. Very well. Then we go to 1 and then minus 2. So when x is 1, y is still minus 2. Y still maintains its position at minus 2. Okay? Minus 2. When x is 2, y is what? 0. So when x is 2, y is 0. So we just have it here. Okay? Very well. Then, so we have when x is 2, y is 0. Then we have when x is 3, y is 4. So when x is 3, y is still 4. So 4 here. Very good. And then finally when x is 4, y is 10. So when x is 4, y is 10. Over here. Good. So with this, we have a very nice plot here. Okay. So the next thing you need to do is to join all the points the way they look. Now, anytime you meet a quadratic equation, and then you are having 2 points meet at a place like this, a quadratic graph specifically, and then we have this and that on the same line, that should tell you that they want you to turn around that area. Or let's say you have met a point like this. You are plotting, you meet a point like this, and then there was another point like that. It means that this one specifically, you come and you turn on the point below and go up. Right? So it means that this is the minimum value, the lowest point of what? Your curve. Right? Good. But if in case that third one is not given, only this and that, then when you are coming, you will decide where to curve it. But you should curve it intelligently, that it's not too much V-shaped, okay, because it's supposed to be a curve. So it's not too much V-shaped, and it's not too much flat like this, okay. That's too sharp. You have several minimum values. So you must always curve it such a way that it should be able to make sense like this. Okay, it should make sense, a lot of sense. So that if I'm looking for the minimum value, I can only trace it to my y-axis. Okay, so good. So this one here, we have that. So we then plot this, and then we rule our lines now. So let's join the point. Always start from the first point, don't extend it. Start from this place and then join the lines. Okay. This is a freehand work. So just don't go using your ruler to join them. So this is a freehand work. My graph is there. Then you go downward. Okay. Then you go here. And like I said, between these two, that means you need to curve over there. Per the scale the question has given, we will have challenges over here. But most of the times, these are what I want you to prevent. If you are the one choosing your scale, then I would advise you to actually do that. Okay? Have a situation where your scale will be outside the scope of the graph, right? So when you are choosing it, you can use 2 centimeters to 2 units on the y-axis so that you have it compressed a bit on the graph. Okay. When I'm done, I'll edit it to that way so that we can continue with that. But the question is asking us to use 1 centimeter to 1 unit. So that one, you do not have any choice than to use that. Okay. So then here, we just go on further and then we curve it nicely through this and then through that as well, and then to that. Very well. So you have your curve neatly done. So starting from here through to this and then rising to the highest, right? So then you have to label your curve as well. Y is equal to s squared minus x minus 2. And that one, everybody knows that this is actually the curve you are actually working with. Okay. So now, if you are asked on this specific graph, okay, if you are asked on this graph to find the roots, okay, so for instance, we are asked to determine the roots. So let me clean this side. So the first question they're asking us is what? Find the roots of s squared minus x minus 3 is equal to 0. So we are finding the roots. Okay. So they mean at the situation where y is 0. Or just simply find the roots of what? This equation. No, I think minus 2. Okay. This equation. Very well. Whenever you are asked to find the roots of a quadratic graph, what you need to do is actually go and locate the specific points for which your graph cuts the x-axis on both sides. Okay? Look for the specific point or locate the 2 points where your graph cuts the x-axis. The value for the x over there is what is termed as what? Your roots. Okay? So with this, our graph here, if we are supposed to determine the roots of what the equation we have, we know this is the equation we plotted, so we can use this graph. So when we are asked to determine the roots, then we shall come here, this curve, where does it cut the x-axis? It cuts it here. You see? So it cuts it at this point here. And then this same graph cuts the x-axis here again. So it cuts it at this point. Very well. Then you read the x values that are over there. Okay? You read the value of the x that is at the point where it cuts. You read the x value that is here. So this one, unfortunately, is cutting it as well. -1. And then here it's cutting it as well. 2. Right. So then the roots of my equation, okay, then the roots is going to be what? X is equal to what? -1. And then what? X is equal to 2. So those are the 2 places where this graph actually what? Cuts the x-axis. So like we said, you can also use the graph to find the roots of the equation. Okay? Provided you plot it, then you are going to look at the places where the graph cuts the x-axis. That is because at that point, y is what? 0. And you know, whenever you are finding root of quadratic equation, you have to equate it to 0. So your function y, the value is 0. Very well. Now, supposing we go on, and then this question asks us to find the line of symmetry. Okay, the equation of the line of symmetry, right? The equation of the line of symmetry. Now, when you look at this, okay, this is a perfect curve that is coming and then goes down upwards. So when we are saying something should be what? Line of what? Symmetry. That means it should be a straight line that should divide this curve into equal halves. For instance, we are having this as our curve and we want the line of symmetry. It means that a line that should be able to cut this curve such that here should be equal to what? This place. That's why I said these quadratic curves, they only exhibit bilateral symmetry. Only one symmetry. Okay, so normally, always, the line of symmetry is supposed to pass through the minimum point of what? Your curve, or the maximum point of your curve. Okay, the line of symmetry is supposed to be a straight vertical line that is passing through the minimum point of your curve. So for instance, if I have a curve like this and I've been able to locate this point here as the minimum, then the line of symmetry should be a straight line that must start from the top and must cut this way, right? And then wherever it touches the x is going to be the equation of the line of what? Symmetry. So for instance, here we curved it, but we know that the distance from here to here, definitely the center there is here. Okay, so we can say that, okay, so here should be our minimum curve. So when we send it to our y-axis, we can read the value of what? The minimum point, right? So when we are looking for the line of symmetry, then that means that line of symmetry should be a straight line that's supposed to pass through this curve, right, at the point of the minimum, like at the minimum point, okay? And then we can see clearly that this line is able to divide this into what? Equal halves. If we should look at here it is what? 2.5. Here is also 2.5. You can see that. So this line is actually the line of symmetry for this our specific what? Curve, right? That is the line of symmetry for our specific curve. So then when you want to find out what the equation of the line of symmetry is, then we'll just like read this. You see this straight line here comes to cut the x-axis at what? 0.5. Okay? You can read it and it cuts the x-axis at what? 0.5. Therefore, the equation of the line of symmetry is what? X is equal to 0.5. Okay? X is equal to 0.5. So like I said, you will always draw a straight line to pass through the minimum point. And where that straight line cuts the x-axis becomes what? Your equation of the line of symmetry. Okay? The equation of the line of symmetry. Very well. Now, if we have this, and then the third question is asking us to find a gradient, of the curve. Find the gradient of the curve at where? X is equal to 2. X is equal to say minus 2. Okay. So find the gradient of the curve at x is equal to minus 2. This is what the question is asking you to do. Now when this is given to you, like I said, I explained earlier, you have to actually locate where is this x is equal to minus 2. So it's here, right? This is minus 2 on the x-axis. So trace it. Trace this minus 2 up to where? To touch the curve. So it touches the curve here. Are you okay? So where it touches the curve, the place where it touches the curve, you can draw a straight line. Please, this straight line should not interfere. You shouldn't cross it like this. You shouldn't cross it like this. But it should be a straight line that is what? Outside. If possible, asymptotic to the curve. Okay, it should be outside the curve, but it must touch the curve at that point. Okay, so you must draw a line that will be outside the curve, but must touch the curve at that point. What I mean by that is, let me demonstrate that here for you to see. Okay, let me demonstrate that. So this, I have my curve here. Good. I have this side done. Okay. Good. And then I have these points here. And we are supposed to find the gradient right at x is equal to say 1. And then when I trace my x is equal to 1, it touches the curve at this point. Just like we trace the x is equal to 2, it touches the curve at this point. Then now, we are supposed to rule a line that is asymptotic to this. It mustn't touch it, as if it's close, but it's not close. And it mustn't cross it, but it must go beside it and then touch it at that point. Okay? When you use a rule, you can draw a nicer line. So it must touch it at that point. So it mustn't touch it so much like this. No. It must make sure that it touches it at that specific point that you are having. Okay? It touches the curve at that specific point. Okay? Good. Now, when you get that idea, you can do same here. Okay? Let me see. Get my ruler. Let's try that. Okay. So, say this. I'm trying to look for the gradient here, so I'll try and draw the line. You see? So when you draw this line here, this line is virtually going to be like this. Good. So if this line is like that, you realize that it hasn't eaten into this, it hasn't done that, but it has been able to touch the points which we are looking at. Okay. Now whenever it touches the points, then what we need to do is that we pick any 2 points on this line. So we pick any 2 points on this line. So here, this line you drew, any 2 points. So this point here, this is 1 point, and then this is what? Another point. Any 2 points on the line you drew. Okay. It can be, but it should be quite wide. Any 2 points on the line. Okay. Now, when we pick the points, let's say we name this point 1, and then we're at point 2. We are still on finding the gradient on the line. Okay. So when you draw the line, you pick 2 points on this line. Then what next you need to do is to actually read the coordinates of what? The 2 points that you have. You need to read the coordinates. So the coordinates of point P1 is what? You read the x value and then you read the y value. Okay? You read the x value and then you read the y value. So the x value for this one is, I'm having minus 2.5. So it's going to be minus 2.5. And then the y value for this is going to be what? 6. Okay, minus 2.5 and 6. So this is going to be 6. That's point 1. Then I'll come to point 2. When I pick point 2 as well, I'll read the x value. Okay, I'll read the x value. and I read what? The y value of this. Right. So the x value here is going to be minus 1. Then what? Point this. Minus 1.5, right? And then the y value is going to be 1 up to 0.7. Okay? So 1.7 minus 1.5. So this is minus 1.5, then 1.7. You get it right? So that is the 2 points that we are having on the line we drew. So once again, anytime they ask you to find a gradient of a curve at a certain point or at a certain place or whatever on the x, come to that x value, locate that value, trace it till it touches there. Okay. Now draw a straight line to touch that point outside the curve. Okay. And then you pick 2 points on the line you drew. Okay. When you pick the 2 points on the line, then you read the coordinates of the 2 points you picked. Okay, so pick points that are at the cross section or the intersections so that you'll be able to easily read it. Okay. Now that I know my 2 points, then we can just apply the knowledge we learned from concept of coordinates to find a gradient. So then the gradient is going to be what? You know, changing y, so y2 minus y1 over x2 minus x1. So this one, y2, you can pick any of them as your y2. Okay, so this is, say, y2, y1. This is y2, x2. Then this is x1, y1. So y2 here is 6 minus y1, which is what? 1.7. Okay. Then divided by, let me clean the roots. Okay. So divided by x2 minus x1. So minus 2.5 minus negative 1.5. Okay. So you are having 6 minus 1.7 divided by minus 2.5 minus 1.5. We are only finding the gradient of these 2 points. Okay. Good. So here you just punch it on your calculator. So you are going to get minus 4.3. Okay. Minus 4.3 as your gradient. So that small question when we were asked to find the gradient of the curve at x is minus 2, that is what it is, minus 4.7. And you understand why the gradient we have is negative, because the line itself is a negative slope. We explained that in our video on coordinates, so you can go and check out that video. Okay. So if you are asked that, locate the points, touch the curve, draw your line, pick 2 points on the line, read the coordinates of what the 2 points you picked, and then apply the gradient formula to get the gradient you are being asked to do. Okay, that's very simple. So gradients, we learned it today. We learned how to find the roots. We learned how to find the line of symmetry, and then we said that when we trace the turning points to our y-axis and we read the value, that is what we call the minimum value or the minimum point. Okay. When we say minimum point, then it's supposed to be the x value and then the y value as a coordinate like this. Okay. But when we say the minimum value, then it's just the answer for the y right there. Okay. So folks, thank you for joining the first part of this our plots. Okay. In our next video, we are going to still maintain this plot and use it to answer other questions. Okay. So see you right there. But make sure before you get there, you've been able to plot this on your own. At least change the scale and then try and see if you can actually do this on your own. Right? When you are done, then see you in the next